Hello everybody, it's great to be with you again, and we're continuing our journey into the land of the hyperbola. Today we're going to do part 2, and that is the geometrical perspective, and that involves when geometry meets algebra, and it's extremely fascinating. So just to let you know that these conic sections have been studied for a very, very long time. In fact, there was a guy called Apollonius from Perga in around 200 BC, wrote an 8-volume treatise on the whole conic section thing and greatly expanded the knowledge of that time. And it's also thought that Euclid of around about that era also had a dabble into it, and I think Archimedes as well. So there's some pretty big names in maths there. So fasten your seatbelts, we're going to have a wonderful time, okay? Here we go. Right. Now, what have I got? The geometry of a hyperbola. It's very similar in form to the locus expression is very similar in form to an ellipse. And why wouldn't it be? Because they're very, very close cousins to each other. So what I'm saying here is, whereas the locus of an ellipse is of this form, which we've already covered in a previous presentation, PA plus PB equals little a, where I'm saying the distance from P back to A, focus number 1, plus the distance from P back to focus number B is some number, little a, which has to be bigger than the distance between A and B, otherwise you haven't got an ellipse. And I've talked about a pin board with thumbtacks pushed in at A and B, capital A and B, and with a string running, little a units long, from A to B, and pulled tight so that it sits there, in that case, symmetrically right on the y-axis at P. That's how it works, yeah? And I've given you an example there where I'm saying that PA plus PB equals 10. Now that would work because the distance between A and B is 8, and 10 is 2 units more than 8, isn't it? Yes. Now we've got our ellipse. Look at that nice little ellipse I'm drawing there for you. That will show you the kind of thing that you will get. It's extremely fascinating, but we're not doing ellipses today, we're doing hyperbolae. So let's have a look at that. It's very similar in the expression, but the shape is different. So we get PA minus PB, not PA plus PB. PA minus PB equals a number little a. So we're saying that what we're saying here is the distance from P back to A is more than the distance from P back to B by little a units, all right? How fascinating. And now this is the really amazing thing, that the beautiful patterns in maths. What we're saying here is that little a in this case has to be less than the distance from A to B, not more but less. And similar things happen as in the case of the ellipse when you start approaching. The value of little a starts to approach the distance between A and B. Things, very, very strange things start to happen. And you will see with great excitement as we go on here. Now there's another example. In this case here we're using the same A and the same B as above, and we're saying that PA minus PB is 3. Now 3 is less than 8, so yes, we're safe. It has to be less than 8, not more than 8. Okay? If it's more than 8, there's no solution. Not any solution. And that's the shape you get. Now, this is the amazing other thing. You only get one branch of the hyperbola, not both branches. And the branch that you get is, if I can put it this way, the one that you're further away from, the focus that you're further away from, in this case A, it bends away from A, okay? It bends away from A, and it kind of bends towards the one that it's closer to and wraps itself around it, if I can use that analogy. Okay? And in actual fact, as you'll see later, as that number 3, in that case, goes up and up and up and up and up more towards 8, it wraps really closely around B and gets closer to B where it hits the x-axis, and it collapses actually into a straight line at, in this case, 8, from B to the right. Just a straight line along the x-axis. How amazing! You'll see that for yourself. Yeah, it's really good. So, okay, we've got a single branch, yes, a single branch, pointing, as I've said, away from the A focus, yeah, the one that's further away from. or the positive term, if you like. The positive term is another way of thinking of it. Now, here comes all my geometrical extravaganza here. Now, there's a lot of extraneous information on these screens because I've borrowed them from a package that I use for classroom demonstration. So, take no notice of that modulus z minus 4 minus modulus z plus 4 equals 0 stuff at the top right, and take no notice of the stuff at the bottom right, because that's all stuff that I use. Which reveals things on the screen and hides them and all kinds of things so that I can maximise the effect when I'm doing the classroom stuff. But I've constructed these loci using circles. It was a fascinating process, but the circles have been used to find the locus of points such that that expression I was dealing with on the previous page is true, and you'll see it. It's really something else. Now this one is the case where I've drawn in, now just don't get confused, I've reversed the position of A and B, I think, compared to the previous screen. Doesn't matter, but A is on the right now and B is on the left, yeah? And the hyperbola is going to bend the other way, just to give you a bit of variety, okay? So PA minus PB is 0. Now, what does that mean? That means that PA equals PB. So the blue line, the y-axis, the blue line going right up and down halfway between A and B is the locus. That means it's a perpendicular bisector of the line from A to B. And that makes sense, doesn't it? You have a look at this. PA equals PB. Now, there's a point P, X and Y, and look, it's equidistant from A and B. And any point along that blue line, that y-axis, that perpendicular bisector of the line joining A and B would be equidistant from A and B for you to see. Now we're starting to show you the trend now. This one here is the case where we're saying that it's PA minus PB equals 2. Same foci, same everything, but you see how it's bending away from the one that it's further from and wrapping itself around the one that it's closer to, in this case B. Okay, and there's 3 possible points for you, P, X and Y. It's good, isn't it? It's just fascinating geometry and how it all works and the beautiful symmetry of it. Anyway, I won't go on. There it is. That's that one. Got it? Now here's the next one. This is 4 now. PA minus PB equals 4. The same foci. And it's bending more, and where it cuts the x-axis, it's getting closer and closer to the left-hand focus. Yeah, that's what it's doing, getting closer to B. And it's yeah, that's how it works. And you can see it's only one branch. It only makes sense to have one branch, doesn't it? There they are. There's 2 possible points for you, P, X and Y. Now we're going to do the next one. I think I'm going up to 6 now. Ooh, is that 6? Yeah, that's 6. Look at it. It's really starting to collapse around the left-hand focus, isn't it? PA minus PB equals 6. And let's label all the points. There's A and B for you and me. Yeah, and what else we got there? There's P. There's P. Good old P. You like it? Now, come on, we're going to do another one now. Here's 7.8. We're getting very close to 8. Remember, 8 is the distance between A and B. So it can't get any more than 8, as I'll explain in a minute. But it's really starting to look a bit sick now, isn't it? It's just wrapping itself right around the left-hand focus, and it's extremely close to it at the point where it cuts through the x-axis. Yeah? It's jolly marvellous. That's what it is. Jolly marvellous. So there you go too. There's all my things all labelled. Very good, very good. Yeah, okay. Now let's have a look at the next one. I couldn't quite get to 8. I think I got to 7.98 because my mouse wasn't sensitive enough on the computer to get it to do 8. So 7.99. That's pretty close, and it's about to collapse into a single straight line emanating from the left-hand focus and going to the left. Because if you think about it, guys, look. Wait, I better label a few points here for you. Now, if you think of a point on the x-axis to the left of B, now you think about that. The distance that it takes to get back to A compared to the distance it takes to get to B, which would have to be along the x-axis, if the point's on the x-axis, will have to be exactly 8 units more because it is 8 units between B and A along a straight line which goes through both of them. See? Now, that's what happens. But if it's more than 8, look, that's a physical impossibility on planet Earth, and you can't argue with nature. It just ain't going to happen. So there's no solution. Right, now I think I've made my point. I think I'm going to, no, what I'm going to do is going to go back and I'm going to show you those in fast motion. I'm going backwards now to the previous screens that I've showed you, and then I'll come forwards again. Right? Okay, ready? Choom, 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 choom. Oh, oh! Now we'll go back again to where we just came from. Choom, 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 choom. Isn't that something? It's really amazing. So, I know. Just push your jaw back up so that it's not dropping so much and your mouth's not gaping, and have a chill pill, because we're going to do some more now. But I wanted to show you the geometry of what happens, as I did show you in the case of the ellipse as well. Okay, as the distance, as the number on the right hand side of that PA plus PB in that case expression was getting less and less and less back towards, say, 8 in this example, yeah? Yeah, and do you remember what happened then? Yes, it degenerated into just a straight line between A and B when the distance was 8 exactly. And then if it was less than 8 for an ellipse, of course, there was no solution. However, I digress. Let's keep going. Now, what have we got to do here? We've got to find the equation of the locus of points satisfying PA minus PB equals 3, where A is the point with coordinates minus 2, 0, and B is the point with coordinates plus 2 and 0. All right. Look, the first thing I check is, what is the distance between A and B? Well, it's 4. And the number on the right-hand side of that expression, PA minus PB equals, is 3. And 3 is less than 4. So yes, we've got a hyperbola. Okay? That's the first thing to check. Now, we're going to do this two ways, everybody. Algebra soup and geometric bliss. I just made that up on the spot. Oh. Algebra method, right, algebra method. Now this is very, very heavy going, so get yourself in four-wheel drive algebra mode, take that chill pill, and here we go. Now here's the graph of it. I always like a little graph because I'm a visual thinker, and I suspect you probably are too. Now, alright, now that's what I'm doing, right? In this case I've got minus 2, 0, 2, 0, that's A and B respectively, and P's up there where I've showed you, and of course the distance has to be 3 units more from P to get back to A than it does to get to B. Right, let's express that algebraically. Let's go. Now, I told you this is algebra soup. Here, look, very thick soup. Pea soup. Now, please do not try to solve that by squaring the left-hand side. You will end up in oblivion algebraically and with a huge algebraic headache. What you do is you take one of those square root signs over to the right hand side the same way as we did in the ellipse version, and then you square both sides. So I'm doing that now. It doesn't matter which term you take over to the right hand side, by the way, it doesn't matter. Now I'm going to square both sides, and be very careful watching how I square the right hand side. Some of you silly sausages do it the wrong way, and I'm going to show you how to do it, because you get confused. It looks so ugly. You're not silly sausages, you're wonderful people, by the way. Right, now, there's the left-hand side squared, no problem. I just took the square root sign away. Right-hand side, now look, that is a compound term. Some of you are tempted to just say, if you look 2 lines up, you'd say 3 squared plus the square root thing squared. Well, it isn't that. Remember, what is A plus B in brackets all squared? It's A squared plus 2AB plus B squared, isn't it? Well, that's the equivalent to what I've done there. So be careful, okay? Just be careful. Don't get overwhelmed with it. It's not unfriendly as long as you go slowly. Okay, what am I going to do now? I'm going to expand it a little bit and leave the square root sign as it is, and try and see if I can do any cleaning up, because it's pretty revolting, isn't it? I think some X's will go, yes, and some Y's will go, yes, and I think even those 4's. Well, that was a pretty good little bonus, wasn't it? Now we better clean it up, mop up. I'm going to get everything that's not a square root thing over the left-hand side, because there's a reason for this. Oh, very nice. Now, I'm a little bit disappointed to look at that, because there's no common factor, and I've got some fairly big numbers. When I start squaring both sides again, which is what I have to do now, it's going to get pretty nasty. However, we'll keep our cool, and we'll be fine. Oh yes, I forgot to tell you, this is a very important juncture in the proceedings. When you get to that expression there where you've cleaned it up and you've got the square root thingy on the right hand side, that gives you a vital clue as to the domain which in turn gives you a vital clue as to which branch of the hyperbola we're talking about. Even if you didn't have the clue from drawing the picture above, I can tell you from drawing the picture it's going to be the right-hand branch because it wraps around the one that it's closer to. But, you know, if you didn't know that, let's confirm it. You've got to say that because the right-hand side is a positive square root expression multiplied by 6, the 6 doesn't matter. It's still a positive square root expression, which has to be greater than or equal to 0. Therefore, the left-hand side must be the same, and that enables you to solve it for what x has got to be. Greater than, in this case, x has to be greater than 9 over 8. So there you go. Now, that is vital information, so I've got a Mr. Redbox coming to help us. Thank you, Mr. Redbox. And we're going to remember that later, okay? Okay, let's keep going now. Part B. We're squaring both sides, and we have to be jolly careful, okay? Because the numbers are going to be big. Well, just think about the mistakes you could make if you didn't be careful there. It's just getting really ugly. However, I think there's a light at the end of the tunnel, providing it's not a train coming the other way, and we can cancel those 144 X's. Well, it wasn't a train coming the other way. It was beautiful. Good. And now there's Mr. Star. Poor old Mr. Snail's having a holiday. He's feeling a little bit slithered out. So Mr. Star's there. Good morning, Mr. Star. And you are a star too for being part of this marvellous little presentation. So thank you for being here. Okay, what have I got now? Oh, this is very easy now. Look, that's a hyperbola if ever I saw one. So let's divide by 63 and see if we can do some cancelling because it looks a bit ugly. Well, look, guys, that first term, what goes into both of those terms? 7, I think, goes into the first one. Yes. And the second one, 9 goes into them, doesn't it? Oh, how beautiful. How very exciting. So now I've got this thing. Hyperbola, hyperbola, I spot a hyperbola, and Mr. Box. Thank you, Mr. Box. And I'm going to now, what did it say to do? Find the equation. Well, I've got to, but the other thing, guys, is I'm just going to do more than that for you to show you how we can then finish it all off and do the whole shooting match. Yeah, it's a hyperbola, centre of the origin. Yes, it is. It's that a shape. It's a left and right shape. A is 3 over 2. Now, this is something I probably haven't explained yet. You know when you have the expression PA minus PB equals 3, well, the A, equivalent to the one in the ellipse in an earlier presentation, A is half of that number on the right-hand side, 3 over 2. And in this case, if it's a left and right hyperbola, A is the distance from the centre where the asymptotes cross horizontally out to the vertex where they meet, where that horizontal line out from the vertex would meet the hyperbola. Okay? That's the deal. And in that case it would be intercepts because the centre is at the origin. Yes, that's what I said. Thank you, Mr. Computer. So, alright, you getting this? It's pretty mighty fine. Right, so let's go. Asymptotes. Now I've done the x-intercepts. There's not going to be any y-intercepts because it's centred at the origin. And it's not off-centre, so that's why we don't have any y-intercepts to worry about. Asymptotes, neglect the 1, and what do we get? We just solve it for y. Y squared is that, so therefore take the square root of both sides, and you get that. Yes, they're the asymptotes, alright? Because you do have to solve for them if you're asked to. If you're asked to draw the graph of it, yes, you would have to. You actually don't have to in this case, they just wanted the equation. But I think... I really feel duty-bound to report the fact that it's only one branch, you know. I don't know whether you'd lose marks for that or not, probably not, but I would report it anyway. However, here it is, the big caveat. Yes, x has got to be greater than or equal to 9 over 8, so which branch is it? Well, look at those intercepts. One of them is not in the running, right-hand branch, only because... You see those intercepts where I've got that a few lines above? X-intercepts are 3 over 2 naught and minus 3 over 2 naught. Well, one of them isn't in this case because x has to be greater than 9 over 8. So therefore only the 3 over 2 one is greater than 9 over 8. So the right-hand intercept up there gets chucked out. Goodbye. No offence, Mr. Other Intercept. I'm going to cross him out now. Oh, bit sad. So, but thank you for trying. We might use you another time. So that's the x-intercept. Oh! Yeah, go back and have another look. Yeah, there's the whole thing, guys. Now, that was it. That was it. It's a lot of algebra, isn't it? A lot of messing around, a lot of opportunities to make a mistake. So here it comes, the drawing. Right, you ready? Look, it looks like a disabled, you know, it looks like he's had an amputation because he's only half there, okay? That's basically the reality of the matter. So I think it's absolutely marvellous. I've had a really good time. We're going to label all the things. And there it is. And how do we feel? Yes, that's how we feel. Absolutely fantastic. And we love it. And you're a star. All right, come on. Now we're going to do it the geometrical way. The same thing the geometric way. And it's, look, this one's geometric bliss as opposed to algebra. What did I say? Algebra soup. Yeah. Okay, you watch this. This is marvellous. Now I'm going to draw a diagram of it, and I'm going to do a particular representation of it in this diagram so that the point P, X and Y is vertically above the focus that it's closer to, alright? Because that enables me to solve just about everything very, very simply about this particular hyperbola. In fact, it's all about finding what B is, because we know what A is automatically. A is 3 over 2, just by looking at the expression you can see above. Yeah, PA minus PB equals 3, therefore A is 3 over 2. Yes, it is. Now, okay, so I'm going to rub out that P, X and Y and put P, 2 and Y, which I've just done. Right? Now, the plot thickens. That distance there, that vertical distance from the right-hand focus up to P is Y units, isn't it? Good. So therefore, what's the hypotenuse? You tell me. How long is that hypotenuse? You tell me. From the left-hand focus to P. Yeah, it's Y plus 3. Or 3 plus Y, as I've written there. So, now why would I do all that? Elementary, my dear folks, because I want to know what the Y coordinate of P is. And I'm going to solve it by using Pythagoras' theorem. Once I get the Y, then I can plug the X and the Y at P, which is after all on the curve, into the expression for the hyperbola, and I'll solve it for B. And then everything is done. How easy. So let's go. Excuse my frog in my throat. Centre is that. There it is. And A is 3 over 2. As I told you. Now, the only thing we don't know is B, and we're going to find that out very simply now. Let's do it. We're saying that PA minus PB equals 3. By Pythagoras' theorem, as I have foreshadowed, in triangle ABP, we know that 3 plus y all squared hypotenuse squared equals 4 squared, which is the distance between A and B, and that 4 is, and plus y squared, the vertical distance from B to P. And we're going to do this. We're going to solve it for y. That's what we're doing, and you'll see. Oh, look at that. That was nice, wasn't it? We cancelled out the y squared. Now we get y equals 7 over 6. Well, that's beautiful. So that point P, vertically above B on the curve, is x is 2 and y is 7 over 6. Okay? Now we're going to plug that into the equation for the hyperbola and solve it for B. And then do, oh, yes, don't you love it? We do love it. We love it. Thank you, Mr. Loveheart. Into the equation of the hyperbola to find B. And it's so simple. So you watch. Good. B. Yeah, B's the unknown. So we're solving for B. But I'm going to plug in X and Y so that B is the only unknown in that expression, as we've just found. There it goes. Yes, yes. Good. Now we've just, it looks a bit ugly, so let's just go carefully and we won't mess it up. I've simplified it. Haven't tried to do too much at once. I'm not being an algebra hero. It's very, very bad to be an algebra hero. Now I'm going to take the 16 over 9 over the other side. And I get that. Yeah, and now there's a minus on either side so I can dispense with the minuses. I'm cross-multiplying. Cross-multiplying. So that's what I get. Okay? You agree? Good, you agree. Alright, so let's just solve it for b squared, because b squared's all we need. B squared's what goes in that expression above for the hyperbola. Okay? Don't need b, just need b squared. Okay. Of course, if you wanted the asymptotes, you'd solve it for b, but we don't necessarily need them. They're only asking us for the equation of the locus, right? Cancel a Rooney. 7 goes into 49 7 times, 9 goes into 36 4 times. So what is it? It's so simple. So there is the missing ingredient. There is the b squared, and therefore our hyperbola is that coming up. Yeah, that's it, guys. And, or if you want to write it a little bit less crazy, you get that. And thank you, Mr. Box. It's mighty fine, mighty fine. Now, I think I've gone to all the trouble of, yes, it is the same as the algebraic solution. It is. So I think I've just shown you a shape up there on the diagram, and it's excellent, isn't it? It's just excellent. Yeah. So that's how to do it with the geometrical bliss way, which, as opposed to that, I think is a lot easier. Let's go back to where we were. And now, this is the last thing for today. This is the other way, the other locus expression for a hyperbola. Okay? Now, let's just recap. This is the directrix and focus way. Okay? Which all those guys in 200 BC, I think, were fiddling around with as well. And it beats me how they did it. I mean, they never had calculators. They hardly even had any writing instruments in those days. It amazes me. And they never even had Arabic number system. I think they were fiddling around with Roman numerals. How would you ever manage with that? I don't know. I take my hat off to them, I tell you. So anyway, meanwhile, back at the ranch, there's the diagram. And now we know that, just recapping, I've written there that if PF equals PM, you got yourself a parabola. If PF is less than PM, you've got an ellipse. And if PF is greater than PM, you've got a hyperbola. Now, that should say PF is greater than PM. I get the silly goat award again. sorry, but you understand, don't you? So, therefore, we do have a hyperbola. We do indeed have a hyperbola. So let's do the algebra way of solving it. Okay, let's go. Right, here we go. Blast off. There's PF, there's 2 times PM. Now PM, look, PM, you've got to get this right. The PM is the distance between P and M, which is the x-coordinate of P minus the x-coordinate of M, which is what gets you x take away -2 or x plus 2. Alright? Right. Now we're going to square. There's no y at all in that because it's a horizontal distance. Right? You get that? Don't mess that one up. It's very clear, very logical. Yeah? Right, squaring both sides. Here we go. And it's that. Remember to square the 2 on the right hand side outside the bracket. You've got to square that as well. And now we're going to expand get rid of the bracket on the right hand side. And then we have to clean up a bit. Now, I don't think there's any obvious cancelling there, unfortunately. So let's... yes, we do love it. We love it. Thank you, Mr. Loveheart, or Mrs. Loveheart, whichever the case may be. And we'll get... Oh, that's nice and simple, isn't it? Now, just check it out. I don't like that negative outside the x squared term. So do you mind if I just reverse the sign of every term by multiplying by -1? Both sides. Yes, that's better. And you can see now, look, I have to complete the square with the x because I've got a middle x term there. There's no such requirement for the y, because that's just y squared, but I do have to fiddle with the x a bit. So this is how I do it, in case you forgot. Take the 3 out, the coefficient out, and put both x terms in the bracket. Now, complete the square in the bracket. Half of 6 is 3, 3 squared is 9. You want 9, and you immediately take it away again, so you're not altering the equation. And then in the next line, you get rid of that -9 outside the bracket, because you don't want that. And you remember to multiply it by 3. Yep, now we're cooking very nicely now. We just have to basically clean up a bit, and we can express that completed square thing as x plus 3 all squared. Nice, isn't it? And I took the 27, the minus 27 over the other side as plus 27, and plus 27 minus 15 is 12. Now we're nearly there now. All we've got to do now is divide by 12. Yep. Hyperbola, hyperbola, no problem. And the centre of the hyperbola is, what is it? Yeah, it's -3 and 0. That's the centre of the hyperbola, isn't it? It is. Thanks, Mr. Box. But. Now, the same argument applies from before. See that thing there? 2x plus 2 has to be positive or 0. Therefore, x is going to be greater than or equal to minus 2. Okay? Greater than or equal to minus 2. So that tells you immediately that you're going to have, if it's greater than minus 2, it tells you you're going to get the right-hand branch. That's what you're going to get, the right-hand branch. So the right-hand branch only, yeah, that's it. Now, okay, you don't have to do this, but I'm just doing it for the sake of completion for you. Okay, x-intercept, right. When y is 0, you've got that equation for the hyperbola we've just determined up in Mr. Box's box with y is 0 in the thing. We're solving it for x. Yeah, here it comes. There it is. Yeah, but however, just a minute, it's only one branch, so one of them is an imposter. Right, I think I've just discovered the imposter, haven't I? Yes, x has to be greater than or equal to minus 2. So there it is. There's your x-intercept, all right? There's your x-intercept. Now, this is the, remember, yeah, that's the x-intercept, and the centre is at minus 3, okay? The centre is at minus 3 and 0, as I said above, but the x-intercept of the curve itself is at minus 1, if you understand what I'm trying to say with all my rambling. That's it. Now, I've put in a little bit of documentation on the curve, and I'm going to actually go, I think I'm going to work out a little bit more. Yeah, I'm working out the asymptotes now for you. And not that you have to, the question doesn't ask you to, but I'm going to do it for you anyway. There it is. I just neglected the 1 in the expression in the box, second box above, and that's what I got. Now, I'm just documenting it. Look at that nice little bit of a wobbly hyperbola, and I'm putting in the y-intercept for you. That's when x equals 0. Okay, into the equation. And you get that thing when x is 0. I've just done a bit of rearranging over to the other side of the equation as well, with the 3 squared over 4 term 9 over 4 taken over the other side. And what do you get? Minus 5 over 4. That's the right-hand side of the expression. So that's good. Minus y squared over 12 equals minus 5 over 4. So if you solve it for y, you get plus or minus root 15. And I think I've just put that in. Yeah, there for you on the diagram. There it goes. Now we've done everything, absolutely everything. Okay, we haven't drawn the asymptotes in, but that doesn't matter. We weren't required to. Okay, you happy? All right. It was a magnificent expose into the wonder of the hyperbola. So thanks again. If you don't get it, if I went too fast, I was trying to speed up a little bit so I didn't take too long for you, but you can easily review it, look back over it, and you will be amazed with the wonder of the hyperbola, and you'll be able to do them as well. So we'll see you next time. All the best. Bye-bye.